at, students? So I've been using M&Ms a lot to help teach my kids about counting and fraction work. And so now we started to look at what proportion of the M&Ms are blue, which proportion are orange. And so according to the Mars company, 24% of the M&Ms are blue, 20% are orange, 16% are green, 14% are yellow, and then 13% are red and 13% are brown. So Morgan just got a half scoop of M&Ms and she is sorting them by color, and we wanted to see if the proportion from her random sample matches the proportion that the company claims. Now you already have a skill set to be able to analyze this, but you'd have to go one color at a time, which is a little bit tedious. We'd have to look at the blues compared to the population, and then the reds and the browns, and we'd have to go through all colors. So it'd be nice if there was one test for us to see if the claim from the company matches Morgan's sample. Made a table and she found a total that they have 119 M&Ms. Well, that doesn't help because we have our values in percentages. So now Morgan's going to have to find out the expected number out of 119. So with a little help from Mom, we have what we would expect to happen from a sample of 119. Now, Morgan, did they match exactly?
One did.
Oh, which one?
It was red, so we found 15, and expected was 15 for red. We had 15 reds.
Which other one also should have been 15?
The brown, but for brown we had 9. It's a little bit close.
It's a little close, but it's not exactly close, is it? Yeah, so what Morgan's saying is natural variability. We expect it to be a little bit different, but is it so different that we have significant evidence to say maybe the company doesn't have their percentages right? And in order to evaluate that, we're going to need to do a chi-squared test. All right. You can probably eat the M&Ms now.
Yay!
Are you gonna share?
Yeah, and just eat off. Take one at a time.
So let's look at the chi-squared distribution. So you're going to start with a null and an alternate hypothesis. Now your null hypothesis goes back to what we learned from all of our other significance tests. Null means no change. So the company's stated colored distribution for all M&Ms is correct. What they say is true. So the alternate claim is that the company's stated claim is not correct. Maybe there's a calibration malfunction in their machines. So then we look at our table. It's important that we look at the observed versus the expected. So we're going to calculate our test statistic called chi-squared. You take the summation of the observed minus the expected squared, so it doesn't equal 0, all divided by the expected. Okay, so once we get our values for each category, we add them all up. So what I'm showing here is how to calculate chi-squared. Pause if you need to. So I take the observed minus the expected squared divided by the expected amount, sum that up, and I get my chi-squared, which is 11.439. Now we have to ask ourselves, well, is that a big number? Is that significant? So let's get into what the chi-squared distribution and the conditions are to run a test. So chi-squared, the smallest number it can be is 0 because we have that squared value. We're not going to get any negatives. And you do have to look at the degrees of freedom. It's going to change. So it's the number of categories minus 1. Notice this is skewed to the right. The higher your degrees of freedom become, the more approximately normal and less skewed this is going to become. So here's our chi-squared, and this shaded area to the right, that upper tail, is p-value. This is very similar to any of our other significance tests. Well, in order to calculate the p-value using this chi-square distribution, data has to come from a well-designed random sample or a randomized experiment. So that's one condition that has to be met, similar to our other significance tests that we've looked at. Also, we're going to need to make sure we have independence. Okay, so either you sample with replacement, which Morgan didn't. She just got a random sample out of a big bag of M&Ms, or you check that N is less than 10% of the population, which in this case, her scoop was less than 10% of the population in the bag. And then also make sure data is all in counts and that all the expected counts are at least 5. She had a large enough sample. This is the large enough condition. So now that all those things have been met, we can calculate the p-value. You're going to want to use your calculator or a table for this, but we have to find that area up in the right tail, and I'll show you how to do this on the calculator. To get a p-value of chi-squared is greater than 11.44, that is a 4.3% chance. Now we have to ask ourselves, well, is this significant? Do we have significant evidence? It goes back to whatever the alpha was. With a standard alpha level of 5%, we would have significant evidence to reject the claim. The p-value is lower than alpha. The p-value is low, reject the hope. We have evidence to say that the company's claim for M&M distribution is not correct. I probably would want to go and do more samples. That would make Morgan and Addie happy because they'd get more M&Ms.